students, welcome to the class. So in the last class, as we discussed about the growth of the current in the RL circuit, in the today's class we are going to study the next part of that concept. So that is nothing but the decay of the current in the RL circuit. So whether the current increases means that is we are calling it as growth. If the current decreases, then we call it as what? Decay. So for all those things we need a RL circuit. So I drawn a RL circuit here. So the circuit which containing resistance, inductance, that is L, which are connected to the what? Battery, isn't it? See, the resistor as well as inductor, both the electrical instruments are connected to the what? Battery, and also connected to the what? Plug key. So these two instruments are connected in series with the what? Battery, means end to end connection we are having here. So this is called as what? RL circuit. So the main components of the RL circuit is, one is resistor and another one is inductor. So already we are familiar about the resistor as well as inductor. So resistor is an electrical instrument which opposes the flow of the current. See, once if you close the plug key, then what will happen? The battery will supply the EMF, so nothing but voltage. So due to that, the current starts to flow in the what? Circuit. So the current will be flowing in the circuit. What the resistor role is, it will oppose that flow of the current. So whatever current is flowing, no, it will oppose to that current. So that is the role of the what? Resistor. Now coming to the inductor. So what it does? See, when the time is 0 second, means before closing the plug key, we can say the time is 0 second. That time the current in the circuit will be what? 0, because there is no voltage, so there is no current in the what? Circuit. So whenever time is 0 second, the current in the circuit is nothing but what? 0 ampere we can call. Now if it is the case, then what will happen? There will be no current, so there is no opposition from the resistor as well as there is no opposition from the what? Inductor. Now if you press the plug key, then what will happen? The whatever the current is there, that is 0 ampere, it will not suddenly increase to the maximum current. So let it be the maximum current in the circuit, I will take it as what? I0. So when time will be maximum, we can say when maximum time reaches, then the current in the circuit also increases to what? Maximum value. So that we are calling it as what? I0. When the time is 0 second, there is no current in the circuit, and as the time will be maximum, the current reaches in the circuit is also what? Maximum current we are getting. That is what I0 we are saying. But as soon as you will press the key, suddenly the current will not increase from 0 to what? I0. So I will give the example. Suppose we are something giving voltage from the battery. So the maximum current in the circuit flowing will be taken it as 3 ampere. So starting it is 0, but once if you press the key, the current in the circuit will not equal to the what? 3 ampere at the next second, isn't it? So what will happen? The current gradually goes on increases and increases. So 0 to 3 it should increase. So how it will be moving? 0, 0.1, 0.2. So 1 it will reach 1.1, 1.2, 2 it reaches 2.1, 2.2, 2.3, like that it gradually increases to what? 3 ampere. So suddenly it will not increases to what? 3 ampere. The reason for this is as it contains the what? Inductor. So here inductor is there. So that is what the thing is. Resistor only opposes the flow of the current, but at the same time, the whatever the inductor is there, it opposes the change of the current. See, when it is moving from 0 to 3, gradually the current is increasing. So we can call it as what? The current is changing. How time is running, the current goes on changing. So that change of current will be opposed by the what? Inductor. It will be opposed by the what? Inductor. So that all we studied in the previous class. So due to that opposition, there will be self-induced EMF in the what? Inductor. It induces the EMF. See, whatever the battery is there, it is giving the EMF is equal to E. If I say that the inductor, when current gradually increases, the inductor opposes that current. So due to that, there will be what? Self-induced EMF here. So whatever the EMF induced is, we can take it as what? Minus E1, because it is opposing that current. So that's what we are taking it as what? Minus E1. Now due to that, there will be in the whole circuit. So what the equation we are getting? So we know the voltage across the resistor is equal to how much? That is V1 is equal to I into R we will take. And when the total EMF, what we are giving, it is E, isn't it? So the total EMF given by the battery is E. But as it is also induces the EMF which is opposite to that one, isn't it? So that is what? Minus V1 we will take. So which is equal to the whatever the voltage is there across the what? Resistor. So that one I will write as what? E2. Understanding? So the total EMF whatever you are supplying, that will be opposite from the what? Inductor. So that's what we taken minus E1, which both be equal to what? E2, which is equal to what? E2. So now if I substitute the value, what we will get? We are getting E minus. So what is the E1 value? Self-induced EMF. Yeah, that is equal to L into di divided by what? Dt. There will be what? Self-induced EMF, which is equal to L into di by dt. So this is equal to what? The current voltage. That is what? I into R according to the Ohm's law. So already we studied this one in the last class. So just I am taking the revision of that one. Okay. So now we got the equation. What equation? So E is equal to I into R. I am keeping there and transferring this minus L into di by dt term to this side. So what we will get? Yeah, we are getting plus L into di divided by what? Dt. So we are getting what? E is equal to I into R plus L into di by dt. So this is for RL circuit. We are having the equation. That is the total EMF will be distributed among these two. That is what? In the resistor the voltage is higher, and in the inductor the voltage will be what? L into di divided by dt. So this is what your final equation. So from this equation we are going to derive the growth of the current as well as the decay of the current. So now I am taking that equation. That is E is equal to I into R plus L into di divided by dt. So this is our first equation. We can say this is what the first equation. So now this is the case when we will press the key. Okay. So already we pressed the key and also we studied what will be the growth of the current. So what will be the changes that current. So now what is happening? We are whatever that pressed key is there, we should release that key, isn't it? We should open that key. So if you do like that, then what will happen? It is a reversal way we are getting. So now when time is 0 second means before releasing the key, means already the key is pressed. So at time 0 second means before releasing the key, what will be the current in the circuit? So already it is pressed, isn't it? So at the 0 second, what will be the current in the circuit? Yeah, maximum current will be, it is reaching, isn't it? So that is what I0. So before pressing the key, the current in the circuit is nothing but what? I0. Now how time will be running? Means when it reaches to the maximum value, the current, so now you release the key, isn't it? So starting it is maximum current is there in the circuit. So once if you release the current gradually goes on decreases and finally it reaches to what? 0 value. So finally it is reaching to the 0 value. Just opposed to the what? Growth of the current. Say in the growth of the current we are pressing the key. So at time 0 second there is no current, and as you press the key, the current is gradually increases and it reaches to a maximum value of what? I0. So now already it is pressed. Now in the decay of a current means the current should goes on decreasing. So we are releasing that key. So while releasing, what will happen? There will be maximum current in the circuit. That is what I not. So once if you release, the current gradually decreases and decreases, and it reaches to what? Zero value. It reaches to zero value. So once you understand that whatever the inductor is there, it will oppose only the change of the current. Change of the current means if current increases, it opposes. If current decreases, then also it opposes. But if a constant current is flowing in the circuit, then the inductor will not oppose that current if a constant current is there, isn't it? See, once it reaches to the I0, means a maximum value, then it will not increase more than that. So as I said the example, 0 to maximum 3 ampere of current if we are supplying, then once it reaches to 3 ampere, then it will not over that one. Nothing but 4 ampere, 5 ampere current we won't get one, because that much voltage is supplied from the battery. So once it reaches to the maximum value, then if time will be running, then also the same current, that is I0 current, starts to flow in the water circuit. So that time there is no play of a what? Inductor. So the inductor will not oppose. So that time only the resistor will be what? Opposing to that current. So this is what the thing. Now again, once the current goes on decreases, it will oppose because current is changing. But again, once if it reaches to the zero value, there is no opposition from the what? Inductor. So once current, if it is constant, means maximum, there is no play of the inductor, and once current reaches to zero, then also there is no opposition from the what? Inductor. So now the thing is, we are having this derivation. So that is the decay of current in the RL circuit. So now we are releasing the key. So at time 0 second, maximum current was there in the circuit. So once if you release, the current gradually decreases and it reaches to what? Zero value. Now if it is the case, so if you release the key, then whether the voltage shall be get from the battery or not. So you are opening the key. So if you open the key, then whether the battery works or not. So yeah, that time there is no play or there is no function of the what? Battery, because we released the key. Only if you press the key, then only the circuit will be completing, the battery supplying the voltage. But once if you release, there is no function of the what? Battery. It won't give the what? Voltage. So that time what will be the E value there? Yeah, E is equal to what we will get? 0 we will get, because we released the key. So if E becomes 0, then what will be the equation? Yeah, equation 1 is equal to 0 we will get. That is I into R plus L into di by dt, which is equal to 0 we got, which is equal to 0. Now what I will do? I will keep this term as it is, and IR term I will transfer to this side, in the RHS side. So what equation you will get? Yeah, you are getting the equation L into di by dt is equal to, so IR, if it is transferred to the RHS side, it becomes minus IR, isn't it? So minus I into R we got. So now we are having two I terms, current terms. One is the di and another one is I. So I will make in one part. So that case I will be coming this side and L divided by dt term will go this side. So what would be the equation? Yeah, equation will be di divided by, so as it is multiplied, it will come to what? Division here. So di by I will get, which is equal to minus R. Already it was there. So L is multiplying. So when it will go? Yeah, it will be divided. And as dt is divided by, when it will go? Yeah, it will be what? Multiply the thing. So we got the thing, di by I is equal to minus R by L into D. So now we are having the integration on both the sides. So if we integrate on both the sides, so what we will get? This is like 1 by x into dx. So what the integration of that? Log x. In the same way, this is 1 by I into di. So what will be the integration? Yeah, of course it will be what? Log I. So log I is equal to resistor and inductor, means resistance and inductance is a constant term. So we are taking outside, that is minus R by L is coming outside. So what is remaining? Integration of dt. So what will be the integration of dt? Yeah, it is plus something integration constant we are getting. So that is nothing but what? K. So while integrating the above equation, we got the equation like log I is equal to minus R by L into T plus K, where K is the integration constant, I is the current at a time t second, R is the resistance and L is the self-inductance, we can say. So now we should find this constant term, that is K value we are finding. So to find that K value, something we should substitute here, isn't it? So shall we take when time is 0 second. So when time is 0 means before releasing the key we can say. So when the time is 0, what is the current in the circuit? Yeah, maximum current will be flowing in the circuit. So when the time is 0, then what is the I value? Yeah, I value is I naught. So if I substitute in the equation this, then what we will get? Yeah, we are getting log of what is the I value? So I value is I naught. So log I naught is equal to minus R by L into T. So what is the time? Time is 0 seconds. So T becomes 0. Means this whole term becomes 0. So what we will get is equal to only K we got. So we got the K value here. Okay. So K value is nothing but what? Log of I naught. So now this K value I am substituting in the, so can I call it as second equation? So I am substituting in the what? Second equation. So if I substitute, what will be our final equation? Yeah, it is log of I is equal to minus R by L into T plus what is the K value? K value is log I naught. So plus log I naught. So this is the equation we got. So again what I will do? I will make the I terms in one side. So this is the I term. I am writing as it is. That is log I. And as log I naught is there, I will take to this side. So it becomes what? Yeah. Minus of log I naught. So which is equal to what we got? Minus R by L into T. So just transfer log I naught to this side. So it becomes minus log I naught. Now if you see the equation, you will come to know this is like log U minus log P. So you know that equation. Log U minus log P is equal to log U divided by P. So in the same way what we will get? Yeah. Log of I divided by I naught. So which is equal to minus R by L into T. We got the equation. So that's what log also I will transfer to make that solution of the equation. That is I by I naught is equal to, so once if log is transferred, so this becomes what? Yeah, e raised to minus R by L into T. So we got I by I naught is equal to e raised to minus R by L into T. That is what R is equal to, so I naught also you transfer. So you will get R is equal to I naught, yeah, into e raised to minus R by L into T. So this is the equation we got. This is the dq of the current in the what? RL circuit. That is I is equal to I naught into e raised to minus R by L into T. Where I is the current at the t second, I naught is the maximum current in the circuit, R is the resistance and L is the what? Inductance. So this is the current, dq of current we can say in the what? RL circuit. Now the thing is to have the time constant value, I am substituting the t value here to find the time constant. So I will tell what is the time constant in the last part. So time constant is nothing but t is equal to the value is L by R. So time constant value is what? L by R. And this t is called as what? time constant. The T is called as what? Time constant. So if I substitute in the equation, then what I will have get? That is I is equal to I naught into e raised to minus r by l is there, and what is the t value? T value is l divided by r. So if I take t is equal to l by r here, l get cancelled, r get cancelled. Are you agree? So both the terms get cancelled. So what you will get? E raised to minus 1 you are getting. As all the terms are cancelled, we are getting e raised to what? Minus 1. So which is r is equal to I naught divided by e raised to minus 1 is there. So to make a positive, I will take to the denominator. So what we get? E raised to plus 1, all divided by e we are getting. So which is equal to I naught divided by, you know already the e value, constant value, which is equal to 2.72. E value is nothing but what? 2.72. That is I is equal to, so 1 divided by 2.72. If you do the calculation, you are getting 0.368 into what is the I naught, that is the maximum value. So this is the I value we got. When time constant is this much. So I is equal to how much you got? 0.368 into I naught. So that is what the I. Now I want to say one important term here, that is the time constant. I said T is equal to L by R, means that is called as what? Time constant. So what is this time constant? I want to say time constant is nothing but what? The time during which the current in the circuit is decreased to 0.368 of maximum current. Say, suppose 100% current is flowing in the circuit. Let it be. If 100% current, if you are giving to the circuit, then out of this 36.8% current to decrease. Out of the 100, 36.8% of current want to decrease. Then how much time that circuit will be taking? Isn't it? So that is called as what? Time constant. Understood? So time constant is the time during which 0.368 of maximum current had been decreased in the circuit. So to decrease 0.368 of maximum current, how much time the circuit had been taken? So that is called as what? Time constant. So time constant means, I will write here. So time constant is nothing but, it is nothing but the time during which, so in terms of percentage I will write, during which 0.368 of maximum current, the time during which 0.368 of maximum current decayed or decreased in the circuit is called as what? Time constant. Okay, for growth of current and for decay of current, there will be some changes is there. So for the growth of current, what the equation you got? Same equation you got in this form. I is equal to, so just see my last video again. So what you will get? I is equal to 0.638 you got. 0.638 into I naught you got. There time constant, what you will give the definition? The time constant means the time during which 0.638 of maximum current increased in the circuit. Isn't it? So out of that 100, to increase 63.8% of maximum current, how much time it is taken? To increase that much current, how much time it has taken is called as what? Time constant. But for decay of current, 0.368 of maximum current to decrease how much time is taken. So that is called as what? Time constant. So time constant for decay of current you should mention there. So time constant for a decay of current is the time during which 0.368 of maximum current had been decreased in the circuit is called as what? Time constant. So now I hope you understood very well, and you got the time constant equation is what? T is equal to L by R, isn't it? So shall I say the time constant depends upon the two things. So first thing, it depends upon the what? Yeah, inductance, and second thing, it depends upon the resistance. So if you see the equation, you will get that the time constant is directly proportional to the inductance. At the same time, the time constant is inversely proportional to the what? Resistance. Means the time constant is more if inductance is more, and the time constant is less if resistance is more. Understanding? So when inductance is high, time constant is high. But if resistance is high, then the time constant will be what? Low, because it is inversely proportional to each other. So this is what the thing about the what? Decay of current. Okay. See, for growth of current as well as for decay of current, same that circuit equation you should draw. So for growth or decay of current for RL circuit, there will be a resistor, inductor, which are connected in series to the what? Battery, and also it contains the what? Plug key. And during a growth of a current, so before pressing the key, there is no current in the circuit. So when time is 0 second, current will be 0. So once if you press the key, then current will not increases to the maximum value suddenly, but it increases in what? Gradually it goes on increases because of the what? The inductor. Resistor is opposes the flow of the current. Inductor opposes the what? Change of the current. So it may increase or it may decrease in the current. It will oppose to that one. So due to that opposition, there will be self-induced EMF in the what? Circuit, in the inductor. So due to that, what equation you are getting? E is equal to I into R plus L into di divided by dt. So if you solve the thing for the growth of current, you will get a certain I is equal to I naught into the bracket 1 minus e raised to minus R by L into t. There will be little bit changes is there in the equation for the growth. So same thing if you solve for the decay, no, you are getting this equation. Just remember the thing, while telling about the decay of the current, you should open the key. You should release the key. While releasing the key, there will not be any EMF from the battery because you released the key. So E becomes 0. So if E becomes 0, then this equation is equal to 0 you will get. And transferring the equation, you are getting minus IR, and integrating the equation. Make I term one side and other terms one side. So you are integrating the equation. So if you integrate the equation, it is like di by I. So log I will get, and as it is constant, you get as it is, and integration of dt is t, and plus something integration constant you are getting. And now to find this integration constant value, that is k value, when time is 0, maximum current would have been there in the circuit. So here we will get confused. So keep in mind, you are releasing the key. So when releasing the key, there will be maximum current in the circuit. That's what when time is 0, maximum current is there. That is I is equal to I naught. So if you substitute, you will get the k value, and putting the k value and again making current terms one side. So you are getting like log u minus log v. So log u divided by v equation will be there. Lastly, transfer log to this side. So it will become e raised to you are getting. And finally, you got I is equal to I naught into e raised to minus r divided by L into t we are getting. Where t is the time constant, which is having the equation L divided by r. So if you substitute L divided by r, all the terms get cancelled, and you got I is equal to I naught into e raised to minus 1, and substituting the e value, you are getting e I is equal to 0.368 into I naught. So where This is the equation when t is this one. That t is called as what? Time constant. And time constant is nothing but the time during which 0.368 of maximum current decreased in the circuit. So to decrease 0.368 of maximum current, how much time the circuit will take, and that is called as what? Time constant. And time constant depends upon how many quantities? Two quantities. One is inductance and another one is resistance. So when L is large, T is large. When R is small, T is large, as it is inversely proportional to each other. So I hope you understood all about the growth and decay of current. So whenever they will ask these things, you should tell in a neat way. So if you see the video, no, you can write the what? Notes also from by seeing the video. So just note on the what? Notes by seeing the video also. Okay. Thank you.